This is Red Ice Radio, a beacon of sanity from Northern Europe. RedIceCreations.com.
And we say welcome, ladies and gentlemen. Thank you for taking some time off in your busy schedule to listen to some Red Ice Radio. I'm Henrik Palmgren. I'll be guiding you through our guests' ideas and theories today. I hope you take the opportunity to sit back and relax wherever you are, as we are going to talk about the delusion of science with British biologist Dr. Rupert Sheldrake today. He has to be one of the world's most innovative scientists. He is the author of more than 80 scientific papers and 10 books, and he's best known for his groundbreaking theory of morphic resonance. Rupert's latest book is The Science Delusion, and we are going to begin with an overview of the 10 Dogmas of Science. These powerful assumptions have led science down the wrong path, according to Rupert. And before we end, we talk about the Large Hadron Collider, the most expensive scientific project in the history of mankind. And Rupert explains that the results in the search for the Higgs field and the so-called God particle might very well be influenced by the intentions of the scientists performing the experiment. All right, welcome to Red Ice Radio, Mr. Sheldrake. Thank you for taking some time off, talking with us today. I know how very, very busy you are, so we do appreciate it very much. Thank you, sir, for coming on.
A pleasure.
Excellent. Now, we have a very short time, as I said here. We have, of course, much to discuss. So why don't we kind of begin to dive right into it? I think we should definitely talk about your latest book, The Science Delusion. It's called Science Set Free in the United States, the US version. And this, of course, follows on from your previous work on the morphic resonance and morphic field and everything else. And maybe we can talk about that later if we have time. But maybe first, Rupert, you can just give us an overview of what the science delusion is.
Sure. Well, the science delusion is the belief that science already understands the nature of reality in principle, leaving only the details to be filled in. Now, a lot of people think that's true. I certainly don't. I think we know a lot, but there's a huge amount we don't know. And in this book, what I do is I take the 10 dogmas of science and I turn these dogmas into questions. So I look at them to see how well they stand up to scientific examination in the light of scientific evidence. And the answer is none of them do. And the point of the book is not anti-science, it's pro-science. I think when we break out of these dogmatic assumptions, then science becomes much more interesting. All sorts of new research becomes possible. All sorts of new questions open up. And so that's really what my book's about. It's an attempt to set science free, as the American title says, from these dogmatic assumptions.
Indeed, and there are about 10 of them in the book, of course, but maybe we can discuss some of the most, I guess, powerful assumptions of science, if that's an easy job to do, Rupert, to kind of distill it even more.
Well, they're all powerful in their own way. I mean, I could summarize them. Should I do that?
Sure,
so
let's do that.
Know what we're talking about.
It's a good idea.
Well, dogma 1 is the assumption that nature is mechanical or machine-like, that everything in nature is like a machine. Animals are like machines, plants are like machines, and we're like machines, lumbering robots, in Richard Dawkins' vivid phrase. Our brains are like genetically programmed computers. So that's the first assumption that's been in science since the 17th century. The second assumption is matter is unconscious. The whole universe is made up of unconscious matter. All of nature is made of unconscious matter. Our bodies are made of unconscious matter. But for some peculiar reason, our brains become conscious. And that is one of the big problems for materialist science. Consciousness ought not to exist at all. The third assumption is the laws of nature are fixed. They were the same at the moment of the Big Bang as they are today, and they'll be the same forever. And so are the constants, which is why they're called constant, things like the speed of light and the gravitational constant. The fourth assumption, the total amount of matter and energy is always the same. It all came into being at the Big Bang. It's been the same ever since, and it'll be the same forever. The fifth assumption is that nature is purposeless. There are no purposes in animals or plants or in life as a whole. And the entire evolutionary process has no purpose. It's just come about by blind chance and the laws of nature. Assumption 6, biological inheritance is material. It's all genetic or epigenetic or possibly in cytoplasmic inheritance, but in any case material. Dogma 7, memories are stored as material traces inside the brain. All your memories are inside your head in some way, stored in nerve endings or phosphorylated proteins, or no one knows quite how, but the assumption is they're all in the brain. Dogma 8 is your mind is inside your head. It's an aspect of the activity of the brain. Dogma 9, psychic phenomena like telepathy are illusory. They appear to exist, but they're not real. That's because the mind's inside the head and can't have any effects at a distance. And Dogma 10 is mechanistic medicine is the only kind that really works. Alternative and complementary therapies may appear to work, but that's only because people would have got better anyway, or it's the placebo effect. And that's why governments and medical research funding and so on funds only mechanistic medicine based on the principle the body is a machine working on chemistry and physics, so it can only be treated chemically or physically by drugs or surgery. And of course that's very effective up to a point, but it's just part of medicine. Anyway, that's the assumption. So these are the 10 assumptions on which the modern mindset is based. Almost all educated people have this as their default worldview because it is the standard view of modern science. But what I show in my book is that when we question these assumptions, every single one of them turns out to be just an assumption. And most of them were put in place in science in the 17th century, some in the 19th century. But in many ways, science has outgrown these old assumptions. The sciences themselves have burst out of them, but most people don't realize that yet.
Well, that's very interesting. Why do you think it is that we haven't kind of left them behind where they belong then in that sense? Why haven't we generally caught up with what we today know?
I think the reason that they haven't really been questioned is partly because the sciences have been so successful. Science has huge prestige. I mean, everybody, all of us, are impressed by the triumphs of modern medicine, the internet, computers, smartphones, jet planes. All of our lives are so surrounded by technology that it seems this entire enterprise, which has changed the world dramatically for good and for ill, is incredibly successful. How could it possibly be wrong? I just don't think it occurs to most people. Most people don't realize these are assumptions. They simply think they're the truth.
Yeah.
And if it wasn't for the success of science, I think they'd have been much more questioned because they're not very plausible when you think about them. But science is so successful, has such high prestige in government, education, business, and so on. It's not something most people think of questioning.
If we talk about the larger context of what all of these assumptions really mean, they have, after all, shaped our worldview, Rupert. And I think you postulated somewhere that it actually might be, we might be on a dangerous path pretty much if we follow through on these assumptions and take them for fact. And one of these is that we can see in our world, of course, the reflection of a soulless outlook, if you will, that we assume that nothing is alive around us. And so maybe you can expand on that a little bit, Rupert. What you see is at the end of it dangerous with this worldview, the scientific worldview that we have today.
Well, I think it's dangerous in quite a lot of ways. First of all, it gives us a false view of nature, that the whole of natural world is just unconscious matter, and that for some mysterious reason we're the only conscious beings in it. Well, maybe along with other mammals or birds or a few other species of animals, or maybe lots of species of animals, but otherwise it's unconscious. And that view, I think, gives us a completely false view of nature and our relationship to nature. And, of course, the ecological crisis shows that there's a terrible imbalance between our activities and the world we live in. And secondly, I think these assumptions alienate ourselves from ourselves because instead of seeing our minds as an aspect of our whole being in the world, an embodied being in the world, we see them as something separate things somehow inside our heads. And it separates our mind from the body and creates a terrible split between reason and emotion and experience, and between science and the humanities, and it creates a whole series of imbalances and splits in our own experience. In medicine, I think it's dangerous because it leads to increasingly expensive one-sided medical systems that are increasingly unaffordable and which ignore everything to do with thoughts, emotions, social life, spiritual beliefs, and so forth. So in many ways, I think it's constricting and harmful, and that's why I think we'd be better off by moving beyond it.
Indeed. I mean, in certain countries now, herbs are banned. Alternative practitioners are viewed as quacks all over. I mean, should we try to... can we disprove these assumptions? Is that what you're trying to do in the book, pretty much,
Oh, yes.
Rupert? Yeah.
Yes. I mean, it's not so much disproving as... The first thing is to bring them into the daylight. When you do that, then they're not so powerful or so frightening. For example, the assumption that matter is unconscious. You have to look into the history, and the history of that belief is, I can briefly sketch it out because it gives an important example of how history is so important here. In the Middle Ages in Europe, the general belief taught in the universities of Europe and through the Roman Church was that nature is alive. The earth is alive, animals and plants are alive, they have souls. This was the doctrine of Aristotle, and it was formulated in a Christianized form by St. Thomas Aquinas. So this doctrine that animals and plants have souls, the animals are called animals because the word anima means soul in Latin. Humans had souls, but everything in nature was alive. The earth was alive, animals and plants were alive, the whole universe was alive, and filled with intelligences, angels, spirits, minds. It was a living world. Now, the whole point about the 17th century revolution was it said, no, it's not a living world, it's a dead world made up of machinery, not organisms. And Descartes, who did so much to formulate this view in the 17th century, proposed that nature is split into two parts. Matter, which is unconscious and mechanical, and that makes up the whole of nature, and mind or spirit, which is conscious and to do with reason, rational thought, mathematics, and science. And reason is that kind of rational mind, which is not in space and time, which is immaterial, is confined to humans, angels, and God. So he made a radical split between humans, angels, and God, which are spiritual, human minds, and everything else in nature, including human bodies, which are unconscious, dead, mechanical, and machine-like. And this split created the split between body and mind, humans and animals, and the rest of nature, and between religion and science. And most of the founders of modern science were quite devout Christians, and it created a kind of way in which people could be religious and scientific at the same time, and that lasted till the 19th century. There was no real conflict, because they were in separate compartments. Religion got the human mind, angels, and God, and science got the whole of nature, including the human body. So the idea that matter is unconscious wasn't proved. It wasn't something that was proved by careful experiments and research and treated as a refutable hypothesis. Mm-hmm. It was simply assumed or defined by a French philosopher in the 17th century as unconscious. That's why this idea is embedded in science. And the next step was in the 19th century. A lot of people didn't like the idea there's two principles in nature, matter and spirit, and they thought there ought to be only one. Personally, I think that we need at least three. But the people who didn't like there being two, Cartesian dualism, some of them said, well, there's only one principle, it's spirit, and that's the idealist philosophy. Everything is consciousness or mind, and matter is kind of dumbed-down mind. Or the other option, which dominated science from the 19th century onwards, is materialism, which says that matter's the only reality. This realm of spirit doesn't exist. It's not material, therefore it doesn't exist. Angels and God are therefore instantly abolished. So you have a kind of atheist worldview. And then the human mind is nothing but the activity of the brain. Now, of course, this assumption, the materialist assumption, is incredibly problematic because although matter is unconscious on this view, we should be unconscious, but actually we're conscious. So how do you explain that?
Right.
And in the philosophy of mind, that's called the hard problem, because no one has an adequate explanation for it. Some philosophers say consciousness doesn't exist. It's just folk psychology, an illusion. Others say it's an epiphenomenon. It's like a shadow of the activity of the brain, but it doesn't do anything. And others just simply say it's an illusion produced by the brain. The trouble is that calling consciousness an illusion doesn't explain consciousness. It presupposes it, because illusion is a mode of consciousness. So this is deeply problematic, and philosophers of the mind go round and round in circles. Most academic philosophers are materialists. They never conclude it, never solve it, and they can't. Some philosophers now today are suggesting that we've got to recognize there's some kind of mind or consciousness in, not just in human brains, but in all matter. Even electrons and atoms have some kind of mental aspect to them. That's a philosophy called panpsychism, the idea of this psyche or mind in everything. And I think that's the only reasonable way forward. And that recognizes a kind of mental life, even in electrons. The philosopher Whitehead, Alfred North Whitehead, suggested that he was the first philosopher to recognize the importance of quantum physics in the 1920s. But because quantum physics shows that matter is not stuff, matter is a process, there's no such thing as instantaneous matter or matter that just continues forever, like hard little billiard balls. Instead, atoms and electrons are waves. And because they're waves, they're processes, and because they're processes, they take time. You can't have an instantaneous wave at a point, at an instant, because a wave takes time. So everything takes time and is therefore in time, and therefore it has a future and a past pole. An electron has a future pole and a past pole. And the future pole is mind-like. It's about possibilities. The past pole is when something's happened, one of these possibilities has happened, it becomes a fact, then it's in the past. And our own minds are like that. Our minds, our conscious minds, are full of possibilities. We choose among possibilities, and possibilities are not physical, actual things, they're just possibilities. As soon as we make a decision among them and do it, then it becomes a measurable fact, and it's now in the past. So the mental pole and the physical pole are poles in time, not in space. Anyway, these are some of the debates going on at the moment within consciousness studies and philosophy of mind, and I think we've moved on from this old-style materialism to something much, much more interesting.
Indeed. I mean, when it comes to proving consciousness from a scientific point of view, I mean, is that ever going to be possible? Because there's different ideas here. Maybe it's the scientific method that is wrong in itself, or as we know, Rupert, you and many other scientists are looking into these things now, but their work is still not really being accepted, if you will. So there's a problem here somewhere. How to begin to move forward, do you think?
Well, I think that there are several things that will move science forward at the moment. One is that in consciousness studies, the problems of materialism are becoming more and more obvious. And a number of eminent philosophers are breaking with it. I mean, a book came out just last month, which I think is very significant. It was by Thomas Nagel, who's a famous American philosopher. And he wrote a book called Mind and Cosmos. The subtitle is Why the Materialist Neo-Darwinian Concept of Nature is Almost Certainly False. And this is one of America's leading philosophers, and it's a very powerful book in that he shows how this worldview simply won't work anymore. So I think there's growing disenchantment with it within the academic world. More important, this worldview is breaking down within the very heartland of biology. The Human Genome Project was supposed to explain human nature in terms of genes. There were billions of dollars spent on it. Everyone said it was going to be this total transformation of our worldview. But actually, it's led to a huge problem. The whole thing is crumbling. There's now something in the last 2 or 3 years, not widely known outside biology, something called the missing heritability problem. What they did was they took the genomes of 30,000 different people they'd sequenced all the DNA and got complete genomes of 30,000 people. And then they looked to see how well they could predict things. They expected they could predict about 80% of what was going on in people from their genes. They started with height. Height's easy to measure, and we already know that tall parents tend to have tall children, and short parents short children. And it's already known that height is 80% heritable, which means you can predict with an accuracy of about 80% the height of children if you know the parents' height, other things being equal, assuming they're not starved or sick or something. Well, when they analyzed the genomes of 30,000 people and looked at their height, they found that out of these, there were about 50 genes concerned with height. And so they made a model to explain height in terms of these genes. Then they tried predicting people's height just on the basis of the genes, not knowing the height of the people. That was sort of kept hidden. Then they tried to predict height on the basis of genes, and they found they could predict it with an accuracy of 5%. Now, you can do it with an accuracy of 80% just with a tape measure, measuring people's height. And after spending billions of dollars, it turned out that the genome was giving predictive accuracies of only about 5% for most characteristics. So the difference between the 80% expected and the 5% achieved, the 75% that's missing, is called the missing heritability problem. And this is a really major crisis in biology. Some geneticists say, we failed. At one or two of them are saying that to do more of this kind of research is throwing good money after bad. And the whole project has failed. Now we need to find out what really does control inheritance, because the genes obviously play a fairly minor part. Other people say, this is just because there must be hundreds more genes involved and we need a few billion more dollars in another 20 years and then we'll figure it all out.
Right.
That's probably the mainstream view. But the fact is that hundreds of billions of dollars were invested in biotechnology and genetic technologies in the 1990s and 2000s. And you remember in the late 90s, we were always being told the 21st century will be the century of biotechnology, and governments were pouring billions into this, and so were private investors. Well, they've lost most of it. A recent report by the Harvard Business School called this the biggest money-losing scheme that's ever been devised.
Wow.
Most of these companies have made no money at all. Governments and investors have lost hundreds of billions of dollars. And so this isn't just some kind of academic discussion. It's something that moved into the business world in a huge way. Countries like Singapore built vast biotechnology hubs because they wanted to be at the center of this brave new world of biotechnology.
Mm-hmm.
You don't hear much about it all now. And so investors are now very reluctant to invest in these kinds of companies, and the rewards of the investment have become very few and far between. So this is changing the whole climate and atmosphere. And within medicine, the promise of genetic medicine and so-called rational drug discovery based on molecular biology, these promises haven't been borne out either. The drug companies are falling off patent cliffs as their patents run out, and they have very few really new drugs in the pipeline. So there's a crisis for the pharmaceutical industry. So it's not as if everything's going to go on in business as usual. There's major crises in the very heart of science in almost every area.
Well, speaking about expensive scientific experiments, what's your view of the Large Hadron Collider and the very expensive search for the Higgs field and the so-called God particle and all that, Rupert?
Well, I mean, I think it's interesting to find out about these particles of matter, but it's extremely expensive, and I think a very disproportionate cost. Because it means other forms of science don't get funded if this one does. I'm afraid I take a slightly cynical view about the Higgs boson. Here we have something that thousands of physicists desperately want to find. We have a huge piece of apparatus costing billions of euros that the grants are running out. They need more money. If they simply said, we haven't found the Higgs boson, the whole of their career, the whole project would just falter. They've got to find the Higgs boson. And Personally, I think this could be an example of mind over matter effects. We know from studies in parapsychology that people, through their intention, can influence quantum random processes. This has been shown over and over again. Here you have 20,000 physicists desperately wanting to find the boson. They know what they want to find. You have an apparatus that sets up extremely indeterminate situations inside it of random quantum processes, and they all desperately want to find it. They have the quantum random process. They're all beaming their thought and intention towards it, and sure enough, it shows up.
Yeah.
Now, is this objectively really there, or is this a mind over matter effect? Now, physicists don't consider the mind over matter possibility because parapsychology is a taboo subject, and they're not allowed to discuss it. But as soon as you take seriously the idea that experimenters can influence the experiment, intentions can affect quantum random processes, then the question of is the Higgs boson real becomes rather an interesting question. I myself think that it's produced by an interaction between the minds of the physicists and the apparatus. You don't always get what you want in experiments, of course, but the experiment is a kind of dialogue between the experimenter and the natural world, and like any dialogue, you can influence the outcome. I myself think that if people become more skeptical about the Higgs boson, and a whole lot of skeptics start saying it's not going to appear, it might become like a battle of minds, and it might start disappearing again. And then they'd have to form even stronger intentions to make it appear. So I think it may be rather an unstable particle. That's my guess. That's
a very interesting take on things. In your view, in what field should there be more investments?
Well, in holistic biology, in holistic and alternative medicine, if we had more research on alternative therapies, there'd be much greater chance of making medicine more effective and cheaper. And what I would do if I ran medical research is have a series of outcome trials or comparative effectiveness research. For example, if someone has lower back pain or migraine headaches, I would take quite a lot of people with those and pay for some of them to go and see acupuncturists, craniosacral osteopaths, or general practitioners and physiotherapists, or homeopaths. Anyone who claimed to be able to cure this, send some people to them and just see what works. And do some of them work better than others? A theory-free trial, a totally pragmatic trial, what works? And if it turns out, for example, that homeopathy works best, then the critics would say, oh, well, that just shows they're getting a bigger placebo effect. But I would say, well, what's wrong with that? If people get better, it doesn't matter what you call it. The only thing that really matters is whether they get better or not. And if they get better for a much cheaper treatment, then that's surely worth knowing. So I would take a completely pragmatic view of this. Instead of having something, only these kinds of therapies can be researched because they fit with this theory, I just see what happens. And I think research of that kind of medicine could transform the medical world and give us a cheaper and more inclusive kind of medical system.
Yeah, indeed. Now, previously you mentioned the Cartesian duality, pretty much matter and spirit. Then you mentioned you think there should be a third in there. What is that third?
Well, I think that in the older view, there was the view of body, soul, and spirit. I think that what we have is, I think there's basically three principles at work, which in physics would be called energy, fields, and consciousness. I think we have three basic principles at work and interacting in the world. Already within physics, within quantum physics, the idea of matter as fundamental has been superseded. Materialism says matter's the only ultimate reality, but physics says matter's not the ultimate reality. Matter, like electrons or protons, are actually vibrations within fields. It's energy bound within fields. So energy and fields are the fundamental principles of nature according to physics. I have no problem with that. And I think some fields interact with fields of consciousness, which are fields of possibility. And so I think we have consciousness, which is the realm of possibility and the ability to choose among possibilities. Fields, which are the organizing fields of gravity, electromagnetism, quantum fields, and my own theory of morphic fields throughout nature, that there are organizing fields of all self-organizing systems which have a kind of memory within them. I think these are part of the field part of nature. And then I think there's the realm of possibility that our minds inhabit. Most of our mental life is unconscious, it's habitual. Our conscious lives are concerned with choosing among possibilities. And that realm of possibility and virtual futures is not exactly the realm of field and habit, nor the realm of energy. It's a third realm. And so I think we have this threefold level of reality, which corresponds in many philosophical systems to theories of ultimate reality which see it in threes. You know, yin and yang in Taoism with the circle that contains them.
Yeah.
Or the Holy Trinity in Christian theology, which is a source, a conscious source of the Word and the Spirit, which are the three aspects of the Trinity. The Spirit is energy, the Word is form, structure, meaning, which I would see as fields. So I think that we see basic threefold or Trinitarian structures in many, in Tantric Hinduism and Buddhism. You have Shiva and Shakti. Shakti is the energy principle, Shiva is the form principle. And it's not just an uncontrolled duality, they're united in a sexual embrace as a part of a larger whole. And so that again is a kind of implicitly Trinitarian principle. I think that seeing things that way makes more sense of nature, and it gets us away from this either unsatisfactory dualism of Descartes, which has dominated Western thought until the 19th century and still is quite an important part of our thinking, or this narrow materialism, which is so out of keeping with the way we experience the world ourselves directly.
Indeed, I agree. Now, there's, of course, endlessly more to talk about here, Rupert, but we'll have to leave it at that for now. You have a train to catch, but I just want to say thank you so much for your time today. And please go ahead and mention your website and the title of your latest book so people know where to go and, what to pick up when they go there.
Good. Well, my website is sheldrake.org, www.sheldrake.org, SHELDRAKE.org. And that has a huge amount of material about my work. It has lots of audio tapes, trialogues with Terence McKenna and Ralph Abraham, videos and so forth, all free. And then I have my new book, which really summarizes a lot of my previous work and puts it in this framework we've just been discussing of science moving on from being stuck in this dogmatic worldview. In Britain, it's called The Science Delusion. It's published in German as Der Wissenschaftswahn. It's in Norwegian. It was published just recently in November in Norway in a Norwegian translation. And in America, it's called Science Set Free, and it was published in the autumn this year. So it's available in various countries in various forms. It's also available as an e-book and an audio book in English. So the details are on Amazon or they're on my website.
All right, very good. Sheldrake.org, the Science Delusion. Go to the website and check it out. Thank you, Rupert, again.
Thank you.
All right, well, this was a shorter program. I hope you enjoyed it nonetheless and got something out of it. We're going to try to get Rupert back with us later in January or February and really get into his theory of morphic resonance, which is fascinating. I hope you had a good year and that you're ready for the new as we begin to look forward to new guests, new ideas, and we're going to continue to develop our program, improve it, and really take things to the next level. We're only really begun and there's so much more to discuss and discover. We here at Red Ice Radio say cheers, and we raise our glasses to you for your continued interest, support, and for staying with us and sending us kind feedback, encouraging words, guest suggestions, and ideas for topics of where to go and where to take the discussion next. For everyone making Red Ice possible, we say thank you, and we'll speak to you soon.